And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks. So without wasting any time, let's get started. Today's problem is container with most water, which is marked as a medium level problem. Let's find out what we will be given into this problem and what we have to do. So we will be given one array ARR of integer types, and each element of this ARR will be representing the height of the vertical lines. Okay, and what we have to do, we have to return the maximum amount of water I can store in these lines. Okay, all right, let's understand this quickly with one test case so that it becomes more clear to you. So here we are given one array with elements 1 5 4 3, which are representing the height of the vertical lines. Okay, so basically if I will make this, so first is this, let's say 1 length, then it is of 5 length, then it is of 4 length, then it is of 3 length. Okay, all right, so these are four vertical lines. And what we have to do, so if I change this language of the problem, we have to find two lines. We have to maximize the amount of water I can store such that we only have to take two lines. Okay, so let's suppose I pick these two lines, so how much water I can store. If I pick this line and this line, how much water I can store. If I can pick this line and this line, how much water I can store. In this way we have to tell how much maximum water, what maximum amount of water I can store by picking any two lines. Okay, all right, so how can we approach this, how can we, let's say, get the solution of it. I think the problem statement will be pretty clear to you. Let's understand this with one more example with some graphs. Okay, so let's see this image which I have downloaded from the lead code. And here we are given these elements in an array ARR, we will say. Okay, all right, and this is, let's say, first wall of length 1, then 8, then 6 2 5 4 8 3 7, and we have to tell how much maximum water I can store by picking only two lines, by picking only two lines. Okay, all right, so let's suppose I picked this line and this line. Okay, all right, so how much water I can store? First of all, what's the length? uh, for one, first length is 1, and another one's wall or height is 7, let's say. Okay, all right, and then what's the difference? What is, let's say I've got the length, and what is the breadth of this? Okay, so first of all, let's decide what's the length, because one line is of height 1 and another line is a height 7. Okay, so we have to always take the minimum of these two, minimum of these two lines, which is equal to 1. Why I will take the minimum? Because guys, look, the issue is here is कि यार, this is 1 and this is 7. So if I take 7, so water filled will be something like this, but it cannot store because this length is this, wall length is only 1. So other amount of water will overflow, and only we can fill till this much, we can fill till this much with water, because we have to have support at both ends. So one wall length is only 1, another wall length is 7. So how much water I can store? One length into, what's the breadth? Breadth is basically 1 2 3 4 5 6 7 8. Okay, so 8 units of water I can store if I pick these two lines, if I pick first line and the last line. Okay, all right, I think this will be very clear to you. So in this way we have to maximize amount of water I can store, and we have to return it. Okay, so let's take another example. Let's take, if I pick these two walls, this wall and this wall. Okay, so what's the length? Length is basically, its length is 6. First wall length is 6, second wall length is 4. And what is the breadth? Breadth is basically 1 2 3 3. Okay, so length is this 6 4. I will always take the minimum of these two, which is 4. So 3 into 4 is equal to 12. So 12 units of water I can store. In this way we have to tell how much maximum water I can store. So if I take the, let's suppose I take these two walls, how much water I can store? Very easy it is. The let's say both length has 8, so 8 will be the length, and breadth will be what? Breadth will be 1 2 3 4 5 5, which is equal to 40. Okay, which is equal to 40. Again, if I will, let's say this first one will remain same, and I take this Okay, so one length is 8, another length is 7. I will take the minimum of these two, which is equal to 7. And what is the breadth? Breadth basically means the distance between these two lines. So it is 1, 2, 3, 4, 5, 6, 7, which is equal to 49. And it is also the maximum amount of water I can store with taking two lines, which is equal to 49, and I will return it. Okay, so in this way, we have to return our answer. Now, the another question which is arising is how are we going to approach this problem? How are we going to approach this problem? First step, first way which is coming in my mind is let's say the brute force approach, where what I will do, I will take two, let's say, nested for loops. First one will be at I, another one will be at I plus 1, which is j will be from this, and now I will be fixed here, and I will move j till the last in this way, and I will calculate the amount of water I can store every time. Like with each pair I will try to calculate amount of water I can store, and I will maximize this. Okay, after that I will be moved to this, and then j will start from here to the last, and again I will try to get what's the maximum amount of water I can store, and in this way we can get our answer. But if I will see the constraints here, constraints are saying ki array size can be as greater as 10 raised to the power 5, and our time complexity is n square, which will be equal to 10 raised to the power 10, and I will get time limit exceed. I will get time limit exceed. So how we can, let's say, optimize our approach? How can we optimize our approach is a very, very good problem. So let's see this. Look, let's say I have two pointers. I will take two pointers. First one is at this end, and another one is at this end. Very starting, very end. Okay, all right. And now I will try to calculate our answer. Let's not answer, current water. Let's say for this pair with the starting at first one and ending at last, what is the amount of water I can store? Minimum of 1 and 7, which is equal to 1, into what is the distance between these two lines, which is equal to 1, 2, 3, 4, 5, 6, 7, 8. Okay, it means I can store 8 amount of water with taking the first line and the last line. Okay, but I have to maximize this 8. I have to maximize this 8. So how I can maximize? Look guys, 1 is shorter and 8 is greater. Let's say this is 7, this is 7, and this is 1. So to maximize, I have to do what? I have to increase our this length is small, this length is smaller, so I have to increase it. And how can I increase it? By doing I plus plus, and now I will be pointing to I will be removed from here. I will be pointing to this. Okay, all right. And j is already at this. Again, I will try to calculate our amount of water. Minimum of 8 and 7, which is equal to 7. And the distance between them is also 7, which is equal to 49. Okay, all right. So again, 49 is there, but I will have to still maximize it. I have to maximize it again. Okay. So what I will do, look, I is 8 and j is 7. So this time I have to increase my j, okay. So to increase my j, what I will do, I will do j minus minus. Now j will be pointing this. Okay. Again, what I will do, again I will try to calculate amount of water I can store, which is equal to j is 3 and I is 7. ARR of j is 3, ARR of I is 8, and the maximum of it is what? Minimum of this is equal to 3, and the distance between them is what? Is equal to 6. So I can store 18 amount of water. Okay. Again, what I will see, look, my j is less than ARR of I. ARRJ is less than ARR of I. So we have to increase our ARRJ, and in order to increase, what I will do, I will simply do j minus minus. J will point to this now. In this way, we will keep on doing, and we can get our answer. But now you will be thinking, ki why I am doing j minus minus and I plus plus? What's the need of this? How are we sure ki we can get our answer maximized in this way? So guys, look, very, very important point it is ki look, if at any point, what I will do, I have to make a draw, something like this. And yeah, so look, very, very important point it is ki first pointer is this, another pointer is this. So if I'm currently at this point, my breadth is maximized. My breadth cannot be greater than this. Okay, all right. But our length is, which of our length is less, I have to increase that. Whichever length of wall is less. Wall is basically, I'm talking about these walls. So which of these is less? I have to increase this. I have to increase that because either way this will decrease only, this will decrease only. So if I want to increase my answer, I have to maximize our length. I have to maximize our length because in each case, this I have already taken the highest breadth when I am starting my process with I at this and j at this. So to increase our answer, I have to increase our length. So that's why whichever length is less, I will try to increase that. Okay, all right. So in this way we will keep on doing and we will get our answer. I hope it will be very very clear to you. And if you have loved the explanation till this point, you guys are with me this point, please subscribe the channel, like the video, and comment it down how was the explanation. Okay, because it will highly motivate me. Okay, all right. So I think now we should go to the code section, and you can also, if let's suppose one length, five length, then there is four length, and then there is three length. Okay, so first pointer one, let's write this one, five, four, three. Okay, so first I will be at this point and J will be at this point, and amount of water which I can store is the minimum of 1 into 3, which is 1, and the distance between these two walls is what, 3. So amount of water I can store is 3. Okay, now I have to maximize this. 1 is less, so I is less, so I will increase my I will be pointing to this. Again, amount of water which I can store is equal to minimum of 5 and 3, which is equal to 3, and the distance between them is 2, which is equal to 6. Okay, all right. And now again, which is less now? Now ARR of j is less. So to increase j, I will move to the left. Now j is pointing to this. Again, amount of water I can store is what? Minimum of 5 and 4 is 4, into the distance between them, which is equal to 1, and it is equal to 4. Okay, so these three walls I am considering, and the maximum amount of water is 6. I will simply return 6. Okay, all right. Now I think it will be very very crystal clear to you. The approach will be also clear to you. So now let's move on to the code section. What I am going to do is, the code is only of 5 lines, so it's very very simple. Int I is equal to 0, j is equal to arr dot length minus 1, and let's take one more variable as answer is equal to 0. Okay, now I will simply write while I is less than j, because I need two walls, and if I is equal to j, it means I have got only one wall, and which is not sufficient. Okay, I at least need two walls to store the water. Okay, so let's say current water, how much I can store. I've already told you how are we going to get it. It will be equal to the math dot minimum of the length of walls, which is equal to ARR of I and ARR of j, and I will multiply it by the distance between these two walls, which is equal to j minus I. Okay, and now what I will do, it is my current water. I will check if my current water which I can store is greater than answer. I will update it. So answer is equal to math dot max of answer comma current water. Okay, all right. And after that, as I've already told, if ARR of I is less than ARR of j, what I will do, I have to increase my I to maximize our, let's say, answer. Otherwise I will do j minus minus, because look, if I is less, ARR of I is less, I will maximize my I, and if ARR j is less, I will have to decrease our j to get the greater answer. My goal is to get the greater answer, and here I will simply return answer. Let's try to submit it directly, and I hope it will get accepted. So guys, please subscribe the channel, like the video, and comment down if you have loved the approach and if you want any improvements. Okay, and download the extension as well, with which you can watch the tutorials here only. I'm going to see you again tomorrow. Till then, keep on coding and bye.